Okay, so this is the first part of the 8.4 section. This is just on what's called the tangent ratio. Before we start that though, I want you to justify why these triangles have to be similar. So this is going back to a few chapters ago when we talked about similarity in triangles. You have to use that information to figure out why these triangles have to be similar. Your answer should be that they have two congruent angles, which means angle-angle justifies that they are similar. What does it mean to be similar? Think back to that definition. In addition to congruent angles, the side lengths have to be proportional, meaning there's a common scale factor when you're comparing. So for example, the ratio of the sides from the little triangle to the big triangle are all the same throughout. HF over JL is the same as GH over KL is the same as GF over KJ. Same if you take the reciprocals. We're going to focus on trigonometry though, and it's going to use that idea of similarity as we move forward. So this refers to the study of triangle measures. We will focus specifically on right triangles. So all the triangles we do in this section are still right triangles, keeping with the same theme. We've been doing the Pythagorean theorem, the 45, 45, 90, 30, 60, 90 triangles, all right triangles. So this idea is going to rely on similarity. We're using the ratio of similar triangles to help us solve for more missing sides. There are three unique ratios we're working with: sine, cosine, and tangent. You've probably seen them on your calculator as sin, cos, and tan. At least that's what they look like. They're pronounced sine, cosine, tangent. We're only going to focus on tangent first. So tangent's a ratio, but it's set up in a specific way relative to one angle. That means the angle you're focusing on controls the ratio you're going to use. We're going to set up tangent next. So for the tangent ratio, we're going to focus on angle A, and the ratio is set up in this specific way for any single angle. The tangent of angle A, which refers to a ratio, is equal to the leg opposite angle A divided by the leg adjacent to angle A. Opposite refers to the side across from the angle, but adjacent refers to the side next to the angle or attached to it, but not the hypotenuse. That's its own separate side. So if we're focusing on angle A, the opposite side is right across the way at BC. The adjacent side is right next door to A, and that's AB. Can't be AC because that's the hypotenuse already. So the tangent of angle A is equal to BC over AB. That's the scale factor, that's the ratio we're using. Angle A can be replaced by any angle except the right angle. So we could be talking about tangent of C, but we will not talk about tangent of B. So to practice writing the ratios, first we're going to write the tangent ratio for angle P and then angle Q. So if we're focusing on angle P, we want to set up the opposite side over the adjacent side. And the opposite side is 15, the adjacent is 8. What I like to do sometimes is circle the actual angle that I'm focusing on so that it helps draw my attention to the correct place. Tangent Q would be the opposite, 8 over 15. What do you notice about those two answers? You should notice that they're reciprocals. They're the exact opposite of each other. So tangent of angle P is 15 divided by 8. The tangent of angle Q is 8 divided by 15. Remember, when I refer to tangent of an angle, it's referring to a scale factor. It's referring to a ratio. One thing you should also know or remember is that angle P and Q are complementary angles. Since angle R is 90 degrees, Q and P have to also be 90 degrees to make the triangle equal 180 degrees total. So you could say the tangent ratios of complementary angles are reciprocals, meaning without a picture, you could still find the tangent of angle Q if you knew the tangent of angle P. So the tangent of angle A, just say it's A over B, talking about side lengths. Well, the tangent of its complement, 90 minus the original number, is the reciprocal, B over A. So let's practice again writing the tangent ratio for angle K and for angle J. You can pause this, I want you to try it on your own, and then I'll show you the video, or the answer. Okay, so the answer you should have is 12 over 5 for K, and tangent J would be 5 over 12, the reciprocal. This is a little extension and connection back to the topic that we just talked about, special right triangles. We're going to find the exact value for tangent of 30 degrees using the picture that you have there. The exact refers to an answer with a square root or a whole number. It's not a decimal. So we want the most simplified version of the answer. Let's start with the 30 degrees. The opposite over adjacent side would be x over x square root 3. The x's will cancel out. Anything divided by itself is 1, so those disappear. You're left with tangent of 30 equals 1 over root 3. We've been here before. Can't have a square root in the denominator. We're going to use the sneaky one trick. We have to readjust the way this number is written so it looks correct. We multiply by the sneaky 1, which is root 3 over root 3. We multiply across the top and across the bottom to get 1 times the square root of 3 over 3. Remember that this root 3 times root 3 on the bottom turns into root 9, which the square root of 9 is 3. So that would be our exact value for tangent 30. But the decimal, we're going to use the regular calculator to find the decimal value of tangent 30. So on your calculator, you can click on the tan button, then 30, then hit enter. You should get this number. If you do not get this number, you need to let me know so I can take a look at your calculator next time I see you. We're going to approximate it to about 3 decimal places, 0.577. So just to sum up, what is tangent of 30? It's a value. It's its own unique number. The calculator has all of these ratios programmed. No matter what the angle value is, the calculator knows what the ratio that goes along with it is. So typing tan 30 into the calculator, it says to the calculator, pull up the right triangle with a 30-degree angle and tell me what the tangent ratio is, the ratio the opposite to adjacent side. Every calculator with a 30-degree angle will have the same ratio for tangent. It'll be approximately 0.577. That is actually the scale factor. Cross out guided practice number 2. We're going to stop here for now.